because now we are a little bit behind. I think we're a little bit behind right now, which is not so good. Shit. Hey, can you all flip to 3.1 and look at the first set of exercises, guys? Which is somewhere around this page here. We haven't done any of these exercises at all, right? Got Huh? We did the first, this three done already. This one? Not yet. How do you know? Okay. Everyone, start doing this page here, guys. I want you all to do the calculation for B and draw me the drawing for C here, guys. What do you want to do again? God, where's my... Huh? Oh, damn. Fine. Okay, hold on. Voltage. Oh, amperes and voltage. Oh, sir, I thought you're in October, November. Your exam is October, November, right? You're in May, June. Why do I keep thinking that? That's move away from more dense to less dense. You're talking about light or what? So this answer here. Less dense to away from if it's a light from more dense to less dense, it went away from the normal, yeah. But for water wave, it will be a different story. You're supposed to identify whether the wave is going to go faster or slower. Yeah, so if it's slower, where should it bend towards? Oh, the accident. Yeah. Alright guys, what's the answer? How much is the wavelength? Oh, sorry, frequency. How much? 1.5 hertz is correct. Anyone couldn't get 1.5 or not? Hey, mate. Hey, anyone couldn't get 1.5 hertz? We'll make this quick. No questions, then we're going to move on straight away. Guys, looking from here, looking at this question once again. If you go from deep into shallow, what's the first thing we think about? Yeah, the speed of wave slows down, right? If the speed of wave slows down, what's going to happen? Will it lag behind or will it lead forward? It will lag behind, so it's supposed to slant towards the left. Once you draw the first two, right, make sure that when you draw the third one, they are all parallel to each other, right? Then after that, you just make sure you just draw. You just draw and draw. And make sure that the wavelength is smaller, guys, but you don't actually need to purposely do that because once you start slanting the wave backwards, guys, once you start lagging the wave backwards, automatically you'll notice that the wavelength becomes smaller, which is in line with the V equals to F lambda formula, guys. Because you know that frequency doesn't change, right? A decrease in the speed is going to decrease the wavelength. Yes?
Teacher,
yeah.
what about the frequency? What happens with
What did I just say?
frequency differences?
Yes. Okay, guys, this one we did already. We did. Oh, okay. Wavelength we calculated also. Oh. Did you do the work or was it because? Oh. We did this already, everyone. Yeah, moving on. Move. Okay, draw this one. Hey, do this question, guys. Oh, by the way, skip A, guys. Oh, wait. Skip it, skip A. Some of you guys haven't learned about sound wave yet. Skip A, do B, C, and D. Yes.
I don't have to.
You're supposed to use the speed equals to the distance over time formula, my friend. What
YouTube. Don't know if that is.
looks wrong?
I don't know if that is true.
That's the wrong formula. So yeah. Yes. This is the wrong drawing. Yeah. Yeah, P equals to distance over time formula. Where's the drawing? Right, this is because 2.94 times 10 to the 1 here. The distance is not 2.5. It's 8 with the area. Okay, everyone, let's go through this question together real quick because we have to cover a few more chapters as well after this. My friends, are you coughing? Are you sick? If you're sick, better wear a mask. Okay, everyone, please pay attention to this question here, guys. Basically, if you look at this question here, blah, 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 not important. But they do say that the compressions are labeled A, B, and ABC, guys. This is one compression, this is another compression, this is another compression. So, first and foremost, let's think back about our basic understanding of wavelength, guys. I said that wavelength is from where to where again? Or how do I define a wavelength usually?
One.
Huh?
It takes the time it takes.
Let's call 1 period for time taken. How are we? It's as soon as it starts repeating itself, right? So I know for a fact that if this is compression and this compression is compression, then this is one wavelength, this is another wavelength, and this is probably half the wavelength lah. Ngamo. That's the first understanding. With that understanding here, right now I look at the information. I have the speed, I have the frequency, and I'm asked to find the wavelength, which is very straightforward. I think most of you guys got this correct. You're supposed to use V equals to F lambda, right? And then your lambda would have been V over F. Then you press in your calculator, 340 divided by 850, you got 0.4 meters, right? Everyone got 0.4 meters? Anyone cannot get 0.4 meters? Okay, then with this understanding, the next question is, they say, how long did it take for A to reach the barrier, guys? A lot of students, they always make this mistake. I noticed they'll tell me that because I told them you're supposed to use speed equals to distance over time formula, right? They'll tell me that the distance is 0.4, guys. But if you take 0.4, right, it will be the time taken for this thing to reach into here, right? But that's not what the question wants, right? It wants from A to the barrier. So I want a time taken from here to here, right? Which means to say I need to find this distance here, right? How long is this distance? How come? 0.4 plus 0.4 plus 0.2, right? So which means to say this is 1 meter ma. Namo. So from there onwards, I'll just know that time is equals to distance over speed, which in this case here will be 1 divided by your speed of 340. Then you press that in your calculator, you'll get something. Units?
Seconds.
Bam. Understand our way, guys? Anyone don't understand this? I saw quite a few of you guys did not do this correctly.
Yes.
Ah.
What is now?
What?
Now.
What?
We're just saying right now. Namo.
Oh, no.
Oh, Namo is correct or not? Wow. I'm surprised you. Okay, good. Okay, can Okay. Okay, everyone understand? Read the question properly, guys. I see a few of you guys wrote 0.4 here. Then after that, they ask you to draw the shape of and compression of B and C. I see you. Some of you guys drew it like this. What's wrong? What did I say when drawing diffraction?
Does not touch the.
Where should it start? It should start from the gap of the barrier, not just suka hati anywhere. So it should start like something like this, right? And this is important. It's actually in the mark scheme. You need to know this. Then after that, the first thing is you need to know that it starts from the opening of the barrier, right? Then the next thing is, what should I be careful of when I'm drawing diffraction? Good, I should draw the wavelength. Should it be the same, smaller, or bigger? It's the same, guys, because the wavelength does not change. I mean to say, if here is 0.4, when you draw this thing here should be 0.4, draw the next one also, it should be 0.4.
How many ends?
Usually draw 3. Usually draw 3. But if you draw 4, it's okay. They don't penalize you. But you have to take into consideration the two things, where it starts and how long the wavelength is. This is important. It shows in the mark scheme, guys. Yeah. You don't have to exactly, but from the eye level, it seems like it's the same. You don't have to do measurement, but you must seemingly from the eye level look like it has the same wavelength. Yes, but for those who have poor perception, I recommend using the ruler as well. You know what you can do with the ruler? You can just literally, like, let's say you put a ruler here, right? And let's say here to here is 0.4, right? Put your ruler here. Every time it reaches 0.4, draw a small dot, then you have a reference, right? You can draw later on, right? You guys get what I mean now, eh? Yeah. Okay, moving on to the next one. So I want to ask you guys this one. Speed of sound of water compared to speed of sound in air. What do you write? Let you guess right now. Same, faster, slower. Slower, you?
Faster.
Faster, you? Huh? Bloody hell. Donkey. Same, faster, or slower? Slower, you? Slower, you? Slower. Faster. Slower. 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 Slow. Faster. For those who said slower, you are correct. Hey? Water compared to sound.
Yeah.
Oh, sorry. It's faster. Sorry, it is faster.
No particles.
Why? How does sound travel? Do you all know or
Particles.
not the basic understanding of sound? How does it travel?
Compression of particles.
No, don't need to talk about compression. How does the energy transfer from my here? Me shouting here right now, how come at the back they can hear it? What's happening?
The particles carrying the vibration.
Very good. It's vibrating the particles, right? Think about it this way: a sound particles in air is going to vibrate, pass on energy, vibrate, pass on energy, vibrate, and eventually reach the other side, right? If it's air compared to water, compared to solids, guys, which one is the fastest?
Solid.
Solids is the fastest. I remember this. You remember this by understanding that sound travels through the vibration of particles, guys. Because it's vibrating the particles, obviously, the closer it is, the easier it is to vibrate and pass on energy, right? Make sense or not? Good. For those who said faster, I'm actually quite glad that you all did not follow the herd mentality because it started with slow. Okay, good. So it's supposed to be faster. Water would be faster, solid would be the fastest. Is this the last question? Yeah. Hey, do this one. Skip A again. Sometimes when my students they don't do well, is it because I'm not giving you guys enough exercises? Is it because I'm not giving you guys enough exercises in class? Huh? Why? How can I help you? Help me help you.
I got the highest in school.
Keep it up. What can I do seriously for? It's a serious question for those who did not do well in your exams, which is essentially everyone from Wesley. What can I do to help you?
Yeah, the Yuan's case is the most common.
No, like Kyle, no, like Kyle, like that, is it?
Easy to easy to
But don't worry, usually the last 3 months we will be like literally doing nothing else but past year papers. On top of the past year papers we do here and the ones that you do in school, hopefully it will be enough. Hopefully. We are planning it to be most likely of one whole day. Oh, guys, you all know already. Gilbert told you guys already. Oh, how do you know about it? Oh, yeah. We're planning to do a holiday program, guys. We did the same thing last year also, but what we do for the holiday program is we're going to be doing a lot. Hey, now that I remember, I didn't ask you yet. How much do you score? Paper 2 out of 40. Okay, not too bad. Oh, paper 4, Okay.
How is 21 not too long?
It's not too bad looking at the average right now.
Fair.
But 28 is good.
Who has me?
Hey, I asked you already, You were 21 or 22, right? You said? You were? The trauma. Okay, guys. So yeah, like I was saying, right, for the holiday program, we're most likely going to be focusing on past year paper attempts, guys. We'll be doing a lot of past year papers. Of course, it's going to be it's going to be a whole new program. I think it'll be 300, if not 350, if I'm not mistaken.
For like the whole day.
For one topic, for one subject, for that program, which I think will run for a week. Yes, it'll be a week. It'll run for a week, probably 5 days. Yes, probably 5 days. And then we'll be doing a lot of past year papers.
Like 5 days morning to evening. Oh.
No, I mean per subject, depending on how many subjects you take. So if let's say you take physics only, it will be like 1 hour, 15 minutes again.
And how much will I have to pay?
Literally just say 300, 350.
Maybe you can cancel.
Okay, anyways, done. Yeah, for those who want to do some extra work during holidays instead of mindlessly scrolling your TikTok,
My mom.
I highly recommend it.
My mom is flying over a tutor from here from. Like
Enjoy your holiday.
a tutor
Okay, good.
for me.
Done. But we'll send out the details by this week. Not like this. Literally do this now, go through the draw like this now.
Which you guys
This doesn't look like 0.4, right? This is one wavelength or. Yeah. Look at this, look at those. What's the difference? Yeah, what?
Is there a big speed for the?
You mean this slanting line here, this printed vector line here? This is the question one. Sometimes you go with this, sometimes you go with this one. It's based on. It's literally testing your understanding. So based on your understanding, either you go like this or you go like this. But in this scenario, this is water wave. Water wave. This is sound wave. Water into water. You know how to know whether you're supposed to cross something or like you ask yourself if let's say the speed was the same, it will be one straight line, right? It will be one straight line, right? It will be one straight line, right? Right now you're speeding up, how come it's even slower than the original line? Just thought slanted to the right. Hey, what? Huh? Find the frequency, yeah, it's in the question. Oh, find the speed then. Find the speed using the wavelength and the frequency. Find the speed using the wavelength and the frequency. The frequency is here, right?
That's it.
How much is the wavelength? How much is the wavelength? No. Read the question. This 0.76 is here to here, right?
0.7.
How do you get this? That's 5 wavelengths, man, here. Where to where is the 5th wavelength? Here to here is 0.76, right? How many wavelengths here to here? This is not one wavelength. Where to where is one wavelength? Here not one wavelength, but here is one wavelength. Bloody hell, that's a whole wavefront, you know. You know. Bro, this is one wavefront, right? Okay, wavefront is peak to peak to peak to peak to peak, right? So where is one wavefront? Or refraction. This is one refraction, this is one refraction, this is one refraction. Read the whole diagram. This is one refraction. So this will be one refraction, this is another refraction, right? So where is on the same time? Shall we? Oh. Here it is one wavelength, another wavelength, another wavelength, another wavelength. Because the understanding is rare fraction, rare fraction, rare fraction, rare fraction, which means to say here repeater, 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 right? Yeah, that's same.
So
So divide by
Yeah.
4.
I just cover around.
Yes. No, you not only you come wrong, you didn't even understood the concept. You grew like your wavelength was like this.
I don't think that.
No,
This is not
this, no.
This is
You
not
see,
wavelength. I think it's called one wave.
this is one way, so this is another, this is.
Then how come what do you find that?
A over here and B over here. We make
But
that
I could like that's a bit.
Your teacher,
Follow my.
teacher.
Why everyone's drawing?
Teacher. Teacher.
I don't know.
Teacher.
Teacher.
Oh my, there is.
Give me a drawing. Yeah. Hey, everyone, listen up. Look at this. Tell me which one is right and which one is wrong.
That one. Wait, that one.
Which one is right?
The right is right. Yes.
Yeah. This is
Yo,
right, right?
See,
This is correct. This is wrong. Why is this wrong? Tell me.
because it's the difference.
What's wrong?
Distance.
The distance between the
Two things.
wavelength is wrong, right? This one. Why the hell am I walking around and realizing everyone is drawing this wrong?
Oh, like, look at this, teacher.
Yes,
Teacher.
0.4.
Hey.
0.4 is
Okay, I get that. Okay, I know why already. Guys, the 0.4 is not to scale.
You just now I asked you 0.4, you say.
No, I thought you asked 0.4. Yeah, this 0.4.
Alright, I run away, then I put 0.4.
Okay, I know already now. Guys, listen up, okay? When you draw this, when you draw this, right, even though, right, I say that here is 0.4, but this is not to scale, my friends. So you can't like really measure 0.4 your ruler and draw like this, right? It doesn't make sense, ma. Ngamo, you have to prioritize. You have to prioritize the damn drawing, right?
How do you respond to Namu, bro? Like to say, yes, I understand.
Nyam,
Nyam, bro.
yeah, nyamo.
Nyam.
I don't know. It's actually pronounced ngamo.
Whatever.
You understand what I'm saying or not? When
Right.
even though Yeah.
I even draw the refractions.
Even though here is 0.4, but here 0.4 is in meters, right? 0.4 meters is at least 40 cm, isn't it? You're not going to draw 40 cm here, are you?
What if I add another?
Yeah, so what you need to do is you need to prioritize the visual length here, and then you draw the visual length here that is the same. You understand what I'm talking about or not?
Yeah.
Yeah.
But teacher, I got another question. The question is equals.
Wait. Wow, I'm getting high blood pressure when I see you guys draw this.
The distance from here to here, like on the ruler.
What? Say that again?
He's saying measure the distance between B and C and measure the distance between
You think
the
that
fraction.
distance?
Okay, I don't know what you're saying, but you can use a ruler and measure how long this thing is here to here.
Then this what you draw on.
Then, yeah, whatever length this is, you draw it on the other side here. My God.
Teacher, I have a question over here.
Yeah.
In question number B, it says on figure 6.1, two refractions A and B are labeled.
And
The distance between refraction A and refraction B is 0.76.
Hmm.
So refraction A is over there, refraction B is over there. There's three more in the middle, right?
3 more in the middle.
Cause like if you see it's labeled refraction, the lines, each line is your refraction. So is it 0.76 divided by 4?
Yeah, Correct.
Exactly, bro.
Why
That's the only one.
Okay, guys, let's go through this question right now.
4.
Aaron, pay attention. Shut up. Pay attention. Everyone, shut up. Hey, guys, if you look at this question here, there are a few key things that you need to look at. First information is that you are given the frequency on the top, right? Which a lot of students, they always miss out on. 7,800 hertz. Then after that, they tell you that from A to B is 0.76 meters. A to B here is 0.76 meters, guys. And once again, if you look at this diagram, it says that these, by the way, what are these lines called again? What are these lines called when you do the drawing? What are these called?
Wavefronts.
Good, it's called wavefronts. Wavefronts are what?
Uh,
Melody, what are wavefronts?
Is that the top view of the wavelength?
Very good. What did he say? Shut up, pay attention. You answer me again. What are wavefronts again? The top view of the... Yeah, so if you look at it from the side view, you'll see this, right? But if you look at it from the top, you'll only see the wavefronts here, right? Which is represented here, here, and here, right? Which means to say each wavefront should represent one... Sorry. Between each wavefront, it should represent one wavelength, guys. So here is one wavelength, here is another wavelength, here is another wavelength, and here is another wavelength. How do I find out how much is the wavelength? Divide by 4. Excellent. 0.76 divided by 4. Yeah. No, from refraction to refraction is one wavelength. Because it starts repeating itself already, right? Yeah. So you'll get 0.19 meters, right? Yeah, good. Then after that, how to do this question?
Speed equals distance over.
Yes, you're supposed to once again use speed equals to distance over time. Your time would be essentially distance over speed, right? So how much is the distance this time?
0.76.
It'll be 0.76. How do I find the speed of the wave?
5928 meters per second.
How do I find?
Frequency times the meter distance.
You're supposed to take frequency times the
Wait, what's the formula?
wavelength.
Yeah, lambda.
Right, which is going to be 0.76 divided by 7,800 multiplied by 0.19. Then you press in the calculator, you'll get something.
It is 1.28 times 10 to the power negative.
1.28.
The bottom one is 1.8. The next one is 6.
7,800 multiplied by 0.19 is like 7,800 divided by 5. How come your number is still so big?
Oh, I didn't.
5.13 times 10 to the power of negative. What's the units?
Seconds.
This is your answer.
Frequency is always unchanged, right?
Yes, correct.
The wavelength will get bigger.
I wanted to ask someone actually.
I don't know.
Let's see. Hey, Elizabeth. What's the answer to this one? C1? Good. Sharifa, what happens to the wavelength? Huh? increase or decrease? Good. How do I know that? How do I know it increases? You. How come it increases? Huh? Very good. According to V equals to F lambda, once again, if the speed increases, your wavelength is going to increase, provided the frequency remains unchanged. Now we got sound wave. This one. Oh, this sound wave going into wood. First question, faster or slower?
Faster.
What? Then
You. Yeah, the sound wave is going to be faster, right? So if it's faster, will it slant? Will it lead forward or will it lag behind? It will lead forward. So you're supposed to slant the line to the right. And you'll notice that automatically the wavelength becomes longer. Yes? Anyone don't understand this? Good. Moving on. Oh. Flip to your 3.2. Please. Guys, we done this already. We drew the Pac-Man already, right? This one. I think we haven't done this, right? Have we done this?
In paper 4, I had to draw the Pac-Man.
Wait. Which one?
You need to do the connect.
Aaron, flip to this page, right?
Teacher.
Yeah.
For a question that says like what's optical fiber used for? For like the previous page, right? In the paper.
Telecommunication or endoscope.
Yeah, I wrote data transmission.
Same thing. Most of you guys didn't do this, right? I think only she did it, right? We done this already?
Yeah.
Why is your empty then?
Yeah, think the dream. Yeah.
Die together, boys. Why is yours empty also?
I had no problem.
How come some of you guys already did it? Some of you guys did not do it? Yeah. Oh. So the online
Yeah,
class
this guy
must
was
be
not
it.
What do you think?
Everyone that did not do this page, do it right now. Show me your answer. Everyone else that did this page already, continue doing until you see the length chapter, which is page 104. Well, you done everything, right? I think even before the exam, you're reading. Stop here, right? This is where it's stopped. I'm gonna go to the seats.
Teacher, what mouse is this?
Stop playing away. Don't move my mouse.
Why does that have so many pieces?
So, boys, what do we do? I'm asked Discord and Roblox, is it? This guy in the toilet, the see do his work was mine. Were you here during the online class? So why the fuck is this empty then?
Yeah, sure. Teacher, I go through that.
Well, I don't know what half of the class did it. Half of the class to play for balls to eat. Definitely wrong.
This
Yeah.
Yes, I know. It's wrong.
It's not.
It's wrong though. Where is the angle from? Here. Is it? That. Yes. You also are. 55 is it? This is wrong. One of you guys tell me why. Your reading is not wrong. But the answer is not 55. One of you guys tell me why. If not, the people will be right.
Outside one, I used to sell it.
Uh-huh.
Because I think minus.
Okay, that's correct. How come?
I mean, what's my doing? Oh, okay, this was
It should be with reference to the what?
most of the distance.
What's the line called at the inside? The one that is 90 degrees on. Very good, you're both safe.
Was.
Skip this. The next one. Hey, you also 55. You went what's the angle? 125. Wrong, and wrong. One of you guys, the reading is not wrong. One of you guys tell me why. It's nothing to do with projector. The projector is already given in the question.
Oh.
Why? Good, why? Yeah. Yes. How many times I say this already? It should be reference to the what? Okay, I just want to know where should the incident angle be? Where to where? Draw on the diagram, show me where should the incident angle be? No need to learn. That's the incident ray. Where should the incident angle be? Where? Okay. Where? Oh. Oh. How long do that? Yeah, how long do that?
This is -25 minus.
Yeah. That should be a calculation as a possible. Hey. Okay. Yeah, by right, if that was correct.
Sign.
Yeah, yes. So it's eventually become sine can be one. No. Yeah.
It's not expected, but others
How come you the one on top and silver?
But I didn't get negative.
Okay, let's go through the answers together. Aaron, shut up. Yeah, I want to ask you guys the first thing, which I think I went around to correct everyone already. I want to mention this one last time, hopefully, but you can sure bet that someone is going to get this wrong again. This angle, everyone likes to write 55, some even write me 125, right? It's wrong because it should be with reference to the norm. The normal, right, my friends? This is the normal, right? So your angle is not going to be here, nor is it going to be here, right? It should only be here, right? Yes, hopefully that this diagram will remind you not to make the same mistake again. Okay, so from here, first and foremost, you're supposed to get 35 lah, right? And then the next question also, I see at least half of the class get wrong. How to do this question? This next one, calculate the angle of refraction in air. What formula should I use? What formula should I use? Okay, good. So most of you guys know that the formula is n equals to sine I over sine R. Right. And then what to do with the numbers? Tell me what to do right now. You tell me what to do. Oh shit, she was the only one that got it correct. Very good. Guys, most of you guys that did the calculation, you all got, I think I saw you guys get somewhere around 27 degrees, right? Hey, if it's 27 degrees, and this one you already found to be 35 degrees, are you telling me that from glass going into air, which is much less dense, the angle became smaller, which means to say the light bended towards the normal? Is this correct? Is this correct? By right, when you go from more dense to less dense, it should bend where? It should bend away from the normal, right? So if anything, whatever angle that you find should be at least above how many degrees? How much? 25. You It should be more than 35 degrees, right? For it to make sense. Do you understand what I'm talking about? I repeat again, your angle here is 35, right? By right, glass into air is supposed to bend where? Towards or away? Away from the normal, right? So this angle here should be at least bigger than, it should be bigger than 35, right? Meaning to say if you find anything less than 35, for sure it's going to be what? It's going to be wrong. So once again, I want to say that when you deal with these kind of questions here, you should remember that this sine I over sine, even though you see this is the annoying part, in your IGCSEs, right? They literally put this to scam you guys, or they ask you to calculate refractive index, refraction angle, which most of you guys will think that is related to this, right? So here is the problem already. It's going to be wrong because the question is literally designed to scam you guys. So you should know that this I should always be the angle that is in air or glass. It should always be in air, and this will be the angle that is inside the what? The glass or the medium line in this case, right? Do your calculation again. Tell me what's the answer for your refraction, angle of refraction. You lost my book or you just left it in school? Seriously, there's one random number in my group right now. I don't know who it is. Can I just kick him?
Text him.
Hey, help me text him.
I go.
Help me text him again. I don't know. I don't want him to feel bad later. He say like, why this teacher don't care about me? Only Alia and Sarah is not here, right? Who else is not here? And Lynn. She's online. So who the hell is the last number? 011 2556 3505. I really don't know who this is. Huh? No lah. Is it? Okay. I've decided I'm gonna kick him out. Why you kick me? I cannot remove people right now. What the hell? Oh. How much is the angle of refraction? You tell me. I don't want those numbers. Give me the refraction angle. How much? 0.33. That's wild. You. Hey. You got to do a lot. How much? Just stare at the question only. Today, don't bring both dots. 80 ah. You Are you sure? Yes, the answer should be 63.5. Hey, you don't know how to. Show me how you do it.
Zero point nine four seven, 0.947, then 0.947. I like put radius. The one.
Then how much the angle?
It's not divide. It's kind of problem. What did you?
What is it?
Yeah.
What? You have six times size of divide. It's not six times ah.
Oh bro, 放到反了。
It's like kind of.
Oh, what is this rules? Side I over side R.
Yes, but I the one in class.
So I
Write it out.
I know what I in
But
class. I
right when
and
zero,
now
nine
it's in R. But the angle is the R, not the I.
equals to
why?
Is this the formula? I and R is the.
how do I find I right now?
不是当爱情那个语言，跟当你在一。
Side is the.
So I is always the medium. Good. Hey,
So how do I?
yeah.
Okay, right.
Medium.
Class, yes.
Good luck. Good luck.
Right.
But now you go worse.
What is minus?
Well, no, not good. So I.
So
但是它很多很发现 isn't even 0.8. It's usually 0.8 next one. Yes.
Actually, yeah.
right now. Whatever you go.
So these.
Yes, Sihan.
Cause.
Do you get it or not? How do I define critical angle? Hey, you. How do I define critical angle?
Index.
Shut up, lah. That's wrong. How to define?
That's the formula science.
Wrong.
One over since.
No. You. How do I define critical angle? Okay, not wrong. You, what do you define? Same thing, ah. Guys, listen up. The easy way to say this is
Oh, define. Oh, I thought how you ask how to calculate with actually the formula.
okay. Guys. Wow, I actually cannot. Critical angle is when maximum refraction occurs, guys, right? Critical angle is when maximum refraction occurs, because if you look, well, I thought I was so angry I couldn't think about the answer for a second, right? Guys, look here. When we talk about critical angle, right, this is going to be maximum refraction, right? Right, cannot refract anymore, ma. The critical angle will cause maximum refraction. So what she said is correct lah, but it's very scientific lah. I usually don't like to write these kind of answers because I know that in the exam I won't be able to write this. We simplify it and we say that is basically the angle where maximum refraction occurs. This is what we call the critical angle. And please write that down. Angle where maximum refraction occurs. And then your critical angle, do you all get 40 degrees? Yeah? But anyone couldn't get 40 degrees? Yes. How much?
21. No, they say like times, but I use divide because of
I told you, right? The angle should be minimum what?
No, because.
Hey, for those who are done with this question, do the next page.
But the ends for because it's how function but something is always there.
But you answered me correctly just now. You said that this should be the one at the bottom.
Yeah, that's definitely like
Do the next page.
Okay. What's the meaning of this again?
Maximum reflection is.
I know which maximum refraction it is. I'll walk around as a local.
Always. This is the formula for reflection based on.
Yes.
And if
I don't want. You think about it. I walk one round and then before I come at over and beat you.
What are you doing?
No, they don't know.
I walk around. Only got time. Oh, you also another one. Huh? Why yeah, that isn't this yeah.
You sure?
Oh, you also another one. Okay, never mind, I walk around first.
Yo.
I just have a look and see first.
This is a kid.
Okay, bro, I don't already know. One is literally air. It's here. One is
Why
air.
you scared?
This is not air. So you
I'm
know.
making glass, ma. Glass, the glass ignores the one front, ma.
Yes, but how come this one also the retreat? If the retreat was the retreat, nothing happened already one.
No, no.
Oh, what am I sure I give you one. I will walk around first.
Hold on.
So I did that, he said no.
Oh shit.
Right.
Did you do sign 21 of that one? Oh shit, they signed.
Oh.
Teacher, this is what I
know.
You can't talk it. That's not teacher. Teacher.
Oh.
The second one, the second one. Teacher.
I do.
Like this. Yeah. Suck my.
I'm back, Darren. Yes.
Let me to miss the shift.
The I will always be the one with air. How much is the air right now?
the air is.
No, I think the angle will be balance of the right way right now. How much?
Yeah, that is what we're
29. After everything we talk about now. After me telling you how to do this question. 29. Why in 33 you can see that? Oh, yeah, is that a reference to the novel? Well, we just look at it in fact now, it's not a reference to the novel. Yes, same. Where's the novel okay? So how is this a reference? As in you were able novel. That's really
You go right, You still with
like these is called reference to the novel.
It's a ratio in the world, but none of you really know.
Someone you have. Let's say, you some yourself. Let's say John.
How is the reference to the novel, right?
Oh, you're good.
Okay, okay.
Badass.
Good.
Still a very one.
What's
the nice one?
I'm not
When you do calculation to the next one, you're actually supposed to use a raw number, not the what's it called, the nice blue. This is not exactly 1/6, right? When you do calculation carry forward, you cannot just use 1/6 here because sometimes it will be wrong.
Just the thing is
So you're
that.
supposed to use like,
No, I usually is not use the skill.
yeah, so one like this, then shift sign.
Like when you in. Your first power of one solution. Eugene.
There's only Eugene in this.
No. No.
There's only Eugene.
Okay, hey guys, last question before we end today.
I got the answer.
What?
38.5.
How come everyone's answer is different? What the hell? Hey everyone, once again, shut up and pay attention. Everyone, I want everyone to look at the screen now, my friends. For those who are still wondering what reference to the normal is, this angle touching the normal is called reference to the normal. This angle touching the normal is called with reference to the normal. So by right, after walking around, everyone figured out that the angle of incidence should be 61, right? And by right, everyone should know that it's sine 61 because I will always be the one in air and it will be sine 33, right? From which you press in the calculator, your refracting index is how much? 1.61. Correct. Okay. But then because guys, listen up, because this number is going to carry forward to the next calculation, right? Do you know that this answer is only correct to 3 significant figures, right? It's not the raw number, guys. When we have calculation bringing forward to the next part, we actually need to use the raw number, guys. Meaning to say in your calculator, right? Whatever that answer is, because you know that right now n equals to 1 over sine c, right? So from here, you're going to get something like sine c equals to 1 over n. And then your c would be shift sine 1 over n, right? You're actually supposed to use the raw number when you do the calculation here.
What if I use 0.60?
You'll be close to correct, but sometimes you will be wrong. How much are we? Critical angle?
I got 38.54.
38.5. Sometimes you see the mark scheme, right? Look here, guys. Sometimes the mark scheme, they'll give you a range, but more often than not, they don't give you a range. In fact, they'll give you just one answer only. But in this question, they give you a range.
That range
And it's not that big only, this range.
is complete.
So for those who did not get this answer, I think you better check your calculation. How much you get? 40 something.
1.6.
Which is wrong.
Teacher, they did 1.6, they didn't use wrong number. But you
What?
are telling us like over there for sine inverse.
When you do the calculation, just bring the raw number to do the calculation.
No, but like they have shown us the calculation step 1 over 1.6.
Listen to me lah. Just listen to me, bro.
Oh, my answer is correct. I thought it was 35.5.
Okay, ladies and gentlemen. How come you go 41? This is not a calculator. It's a phone.
Same damn answer. No, I think it's similar. That's working. No. Okay, different answer. It's not my fault.
Once again, I want to emphasize, bring your calculator to class. Alright guys, we stop class here today. Everyone got your answer already. Our critical angle should be somewhere around 38 point something. 6, maybe 5. Yes. Okay, guys, we stop class here today. You can have your 15 minutes break before we continue with chemistry. For those who are done with physics, see you all next week. Mm-hmm.